Hello friends, welcome to my channel. Today we will discuss about few fundamental concepts inside Rust programming language. For example, variables, constant, how we can print them into the console. We'll talk about array, tuple and struct. I assume you installed this Rust compiler, cargo by following the documentation or my previous video. You can create the basic project using cargo new project name. So you'll have this function.main. Here inside this we'll write our code. This would be the entry point of our program. And to suppress the warning during the demonstration purpose, I am using this line. But this is a not recommended approach. You no need to write this particular line. Now let's get started. The first line of this program is to write some hello prints to the output of the console. To execute this program, we can run cargo run. When you do cargo run, it will compile this program and it will execute this program from this target debug rust ex. One executable will be created. As part of cargo run, it will compile and run as well at the same time. Hello friends. And to speed up our development and demonstration, I am using another command line tool known as cargo watch, passing some parameters. You can see this command in my GitHub profile, GitHub repository. So whenever I change and save it, this particular output in the right hand side will be auto reflected immediately. And this println, if you see the exclamation mark, this stands for macro. Macro is not a normal function. This is specialized kind of functionality provided by Rust. We'll cover in detail in later part of this other video. Similar to println, we have like debug macro, so which will give some additional information apart from this println what it is providing. So if you see in this debug macro, it prints this source code, line number, and in the left hand side the variable name, and right hand side is the value. Because we are giving the value in this directly you are printing, so this variable name is not printed over here. If you use any variable name, it will be displayed over here. Using this let keyword, we can declare and initialize the variable. And if you see this type is auto inferred, we'll talk more detail about various type. And because I am using Rust Analyzer extension, so you can able to see this message I32. I32 stands for signed integer 32-bit integer type. And using this curly bracket syntax, we can print the information. And if you save it, age is 30 is printed. So this two curly bracket is used for the variable substitution. And we can use multiple argument to print different set of variables. So you can use as many as curly bracket and you can give number of different arguments. And not only you can access using this curly bracket which correspond to this word correspond to first one, this one correspond to second one. But if you try to use alternative way in two times, then you can use this argument using the position index as well. Like 0 stands for profile, and if you give 1, it stands for age. This different type of parameter you can give inside this particular two curly bracket. If you want to print this binary 25, the integer number, if you want to convert to binary representation, you can give colon B, or you can give for colon O for octal and hexadecimal and so on. Also, this should be a different syntax, this value and this padding. This you can give any name, and these are two integer data. So here it is giving, like, it will create a padding. You have to remember the syntax: value colon greater than symbol and pad $. So it will append like this many 10 spaces before 5. And if you want to replace space with some other data, for example x, here you can give, you can replace this space with x padding. I'll talk about struct a little bit later, but in the Rust there is no concept of class. So all the data model is represented by struct. If you are coming from C background, so the struct may be familiar with you. So this struct point has two attributes x and y, and I'll go in detail about explanation, but I'll just this part of topic now is just how to print it, how to print a particular struct, and what are the different things you need to consider about it. There is a typo I did, I just corrected it. Point. So let p, this is the same variable. You can initialize or instantiate a, one specific type of point. Here you have to give like value for x and y. And if you try to print using curly bracket, this will complain. This is not a valid syntax how we can print a particular struct instance. So this will lead to a compile error. So point cannot be formatted using the default formatter. And we talk about some trait display. So the trait is a very important concept. Trait is a kind of interface inside Rust. But today I am not going to cover in detail about trait, but we will try to implement this display format in the later point of time, so that this particular functionality will work. We can definitely use curly bracket, but it talk about like we have to provide our own implementation how we want it to display, or how we want to convert this struct representation to a string representation so that it can be printable inside console. Even though you try to debug it, it will still complain. But it is talking, the previous example talk about the display trait, but this debug macro, we talk about the debug trait. And it gives some information how we can put some macro. As I said, like this println, this colon exclamation mark and debug exclamation mark, these two are also macro. And also macro can be written in this format as well. The macro is able to provide some different additional functionality on top of the struct. For example, this derived debug macro, this is very useful, and this by itself will automatically implement the skeleton or the generated code for providing this implementation for trait, so that we can able to print this using debug macro. So you don't have to worry about what are the trait and how to implement, but you can just for understanding sake, you assume that this is a macro. Once you put this line, it will automatically generate some other additional code which will help us to debug this point information or point struct. So if you see this debug macro p, so it printed p is the variable name and this point x and y, it got printed very nicely. But if you try to use this curly bracket again, it will still complain, because this particular macro is only used for, like, you can debug it. You can't convert it to a string representation. But if you try to use like different argument inside this curly bracket, for example colon question mark, so this is here you can able to display it. This converted the normal string representation to debug information. So this colon question mark looks for the debug trait. Only normal curly bracket will looks for the display trait. There is a quite distinction between those two. And also if you use like a pound symbol between this colon and question mark, so it will be printed in a pretty format, neatly organized or indentation and little bit in a formatted manner. Now for the argument's sake of this demonstration purpose, I'll implement the trait, but you don't need to worry about what is the trait and how to implement and all these things. That would be covered in the future videos. But just to give a feel about it, this is the implementation, this is the display trait name, and for the struct. And this is the signature of it, and all the VS Code and other utility will provide the autocomplete of it. You don't need to worry about the signature, but I'll talk about in future video about the self and formatter, what they are doing about. But the idea about is that using this implementation, you can able to print it. So you after write all this, this is the formatter, and this is your same println and syntax, whatever you've seen earlier. Whatever you want, you can write it here. This curly bracket is nothing meaningful. This is a string only, and here this curly bracket will be substituted the value x and y. And to make it work, we have to import that module. For importing module, we can use like use. Use is like import or require in other programming language. This is the module name. Like standard is the root label module name, standard library, and it is a format module, and it has a different functionality. This is some implementation or trait. Okay. So no need to worry about at this moment. I just want to display, give the information that you can able to, if you really want, you can able to implement and provide your own custom display formatter for it, so that if you want, you can using this normal curly bracket also, you can print a particular point. See here, this is our display format, x equal to 5, y equal to 5. You can customize this as per your need, but for the printing this struct, we rarely need it. Most of the debugging purpose, this particular derived debug is more than sufficient. Now let's see some of the other thing. So instead of println, you can use print only. This ln stands for new line it will create, and this won't create a new line if you try to print it. See that message is displayed, and there is no new line after that. And similar to println or print and println, you have eprint and eprintln. Currently there won't be any difference in my output, but usually in if you want to, you can redirect the output of println to the system.out or normal information or debug information, and e.println you want to print the error messages. So you can differentiate or segregate that success or info debug message to one file and error message to another file. And like println, all this curly bracket, string interpolation will work exactly like format, but this won't directly print into any console. So the output is a string. So if you want to concatenate between different string and variables, so you can use this format. This is very heavily used. All the syntax, whatever you learned till now, you can apply in this format as well. And the output you can shout it inside a message or any variable. And if you want to debug it, the same output will be printed. And because you got a string string directly, so you can apply any kind of string related function. For example, if you want to convert to uppercase, so then you can call it to uppercase or to lowercase or any string related function. Yeah, I think I have not noticed it. This is to uppercase, name, profile, age, 30 and so on. And you can use like the normal standard comments. For example, two pipe symbol for the one line comment. And you can use the standard, /* to use the multi-line comment. And usually this is the standard way to write multi-line comment. And there are different types of comment for documentation. This is known as docs comment. // So if you want to generate this documentation, you will see / in many places inside this Rust ecosystem, because the documentation project will be built and created for you. Now we'll talk about primitives. For example, integers, floating point numbers, and etc. And what are the different types available for such kind of type of primitives. So this primitive is also known as scalar types. And we have signed integers and we have unsigned integers. And if you see that like from 8-bit to 64-bit we have I8, I16, 32 and I64 and so on. This is the signed integer, means you can have plus number as well as minus number. Whereas unsigned number, we have the corresponding unsigned integer as well. And this I size, U size is the variable particular bit. It may be 32-bit or 64-bit depending upon your OS architecture. So depending upon your need, you can use like any number. By default, it is U32, I32, but you can use any specific type depending upon your need. And we have two floating points number, F32 and F64. And also Rust has a good support for UTF-18, UTF-8 character or Unicode scalar values. For example, it is a, with single quote, you can give A, but you can give also any kind of Unicode as well. So all the time they are not, 8-bit or thing, they have a different way to represent into the Unicode character. But we'll cover about the Unicode character a little bit detail into the next video. But for simplicity, character you can store like single quote A, B, C, D, and just to start with that, you should be comfortable with on that. And we have another type like bool. It is not boolean, bool. So we can store like true and false. Here, like usually the convention is not camel case, but it is a snake case. Multiple words are usually separated by a underscore. Is underscore morning. This is a convention like most of the Rust programming language uses. Here is a boolean value, you can give false as well as true. And if you give like integer value, then it would be I32. But if you give a dot and 2 precision or any number precision, and by default it is a plotting CT for bit. By default, that is it is inferred. If you give 32, by default it is I32. But if you really want to give a specific type, from this anything you can give, like I 8-bit or 16 bits, then you can give like colon I32. This is also cool compile and valid syntax. And this is a bit strange. Not only it will be auto inferred and you can give here, but I also after the number also you can give this type. 55 is the value, I32 is the type. In this format, like suffix also you can give. And this is very common beginner mistake problem. Once you declare an initial value, but if you can see this, I declare like as multiple times. This is perfectly valid syntax inside Rust. This is known as variable shadowing. So this will go out of scope and as will be 45 and so on. But after this you declare initial value, if you try to do assignment, it won't work. Because by default, the variable is immutable or it cannot be changed. So the assignment will be failing. Cannot assign twice to immutable variables. And to make it mutable, it is very simple. You can use a mute keyword after let mute. So this mute keyword is very commonly used. If you want to change and assign to some different values, you can use mute keyword, then you can be able to change it. And if you debug the information, here you can give as equal to 50. So this is, I feel much more comfortable with the debug. I no need to write this variable name. In println, you have to write the variable name equal to curly bracket. This is a little bit verbose, and this debug maker is a little bit simpler. And you can use all kind of standard mathematical operation like plus, minus, and all this thing. Like 10 plus 20, and if you give like unsigned integer, this will work like 10 plus 20 equal to 30. But if you want to, minus from a unsigned integer, this will complain. Because this will be, this is an unsigned integer. So if you want to minus subtract from an unsigned integer, you can't do that. So you have to make it as an unsigned to a signed integer. Then you will get the result. A minus 10. And all standard boolean operator you can get like 2 ampersand, like and boolean and true and false. This should be false because this and will be evaluated true if both sides will be true, or you can combine to multiple, then every entry should be true, otherwise it will be false. And this is or if one of them is true, then this is evaluated to true. And this negation also we can use. Negation of false equal to true. true and true, false equal to false, then this is true and this is negation of false equal to true. And these are the bitwise operation. It support like bitwise AND and bitwise OR, bitwise JOR, and also left shifting, bitwise left shifting, bitwise right shifting. So these are the bitwise operation are not very commonly used, but wherever you need it, you can leverage that bitwise AND OR and other thing as well. So I'm not going to detail about how these values are calculated, but there is a standard computer science concept. You can refer from that any other article. And plotting value, not only you can give like .00 concept, but it is an integer value. If there is a, you want to represent a number in a different way to be more readable, you can use underscore. Underscore has no significance, it's just for readability purpose only. Under the hood, it will be represented using this 5 million number. Now we'll discuss about tuples. Tuple is a collection of various different data types. In case of an array, you can have a similar data type with number of similar data type values. But in a tuple, you can have collection of different data types. So usually tuple are represented by this lower parenthesis. Here I given two integer values, but you can give like integer, string, and any other combination of data types. So if you notice here, this is a curly bracket, like parenthesis. This is the important part, and you can use like any number of values for your purpose. And this is a destructuring syntax. Just to use here, either you can use variable like any tuple variable, or you can destructure into left side also. You can use parenthesis x comma y, and the type would be inferred. So at later point of time, you can use xy whenever you want. So once I debug it, so xy value will be printed. And you can have the nested tuple as well, like 1, 2, 3, 4, and so on. And if you want to print it, this is a nested object. And if you want to access its individual values, you can use 0. 0 would be printed as first value, 1, 2. And if you want to use nested at 1, the second 3, 4 would be printed. And again, you can use 1.0. Then this second, the first element of second tuple will be printed. But these are the not very meaningful way. You can using the index, you can be able to print 0, 1, and so on. But if you want to destructure it, then you can use this XY syntax. And we'll create a struct representation, similar point we declared earlier, and we'll use the derive macro to print it if you want to so. And in this line, we created a simple p pointer. This point looks like a struct with two attribute. And similar to tuple, we can destructure this point as well to xy. But you have to mention this xy here as well. Point, curly bracket, xy. This is nothing to do with the tuple. This is the struct representation. And this is the instantiation of it. Like, and if you want to access here, you can't access p.x, you can access. Because all the struct attribute do have the attribute name well defined. But inside the tuple, we can't define any attribute name or the argument name. It is completely data. It is up to you to know what is you're storing the values. Now, if you want to convert a point to tuple? This is a function signature, like this is a function name, and this is the argument name. Inside function argument name, you must have to specify the type. And I will talk about more about the borrowing and ownership concept in detail because those are very fundamental concept. But here I am passing the reference, ampersand point. I'm not passing this total ownership of this point, but rather a reference I'm passing. And this is the arrow key followed by the return type. Return type is a tuple. Px, Py. So this xy is printed over here. Okay. So you can convert this print struct type to tuple type. Now we'll discuss about arrays. Arrays is represented by square bracket. We can pass any different values, but the value type should be same. So in Rust it is slightly can be represented slightly different type as well. T stands for type. It may be integer, floating point numbers, or string, followed by a semicolon and the length. And one important point to remember inside array is that each value would be stored in a contiguous memory location, so that the accessing of the memory would be easier. And the length of an array is known as compile time. If you want this compile time, and usually the array with primitives usually stored in a stack memory. But if you want more growable and shrinkable array, so you have to use vectors. There is a clear distinction between array and vector. So array is a static or it is a compile time well-defined length. The length of the length you already know in the compile time only. So you can't take input from some other program or API call and you can store inside an array. And there is another concept known as slice. Slice also length is not known at the compile time. But it is not, it is just a slice of a defined array itself. So it contains the two words. One is pointer. It can point to the 5th element of an array till the 10th element. So it is a slice of a particular array. It can start from any index up to a certain point. It is a kind of substrings of an array. So that is usually used to pass between different functions and as a arguments. So here we define an array of numbers, and if you see this, this is the type input here, I32 colon length. In this case, length is known as the compile time itself. And you can define like you don't need to give the type here. There's a different way to declare an initial as a value. If you give 55 or any value here instead of type, so that it will create an array with 5 elements with the value 55. So if you see this 55 repeated 5 times. And you can access like length using length function, and you can access this array index by 0, 1, 2 and so on. And if you want to access like more values, then it will give a index out of bound exception. So it could not compile it. It is a compile time error. So this is the slide syntax. We can give the ampersand 1 to 3. This is the reference and this is the type. So here we can print it and call this. So you can pass the reference of an array. So it will pass as this signature. Ampersand square bracket I32. And inside this also you can print the length or index or any read-only access you can do. This is not the mutable thing. This you can only do the immutable operation. Now we'll talk about struct. Struct is very important data model because inside Rust we don't have the class. So all the data or attribute will be represented by struct. Struct is very commonly used across the board. So we create like struct. There are three types of struct. One is the normal struct, which is used very commonly with curly bracket and the attribute name. Name, age. If you see that this is the struct name, and here this is the attribute of the field name followed by its type. And here this is a tuple type of struct. This is a struct, but it is a tuple type. Here we don't have the field name, but it is similar to tuple. We can have the different data type with different values here. And then we have very confusing type. We can give any name here. It is an empty name I provided, but this is used mostly for generics, and it is not very commonly used, but it is for just used for some type checking and some other specialized purposes. But here it doesn't store any data. Now let's add the derive debug macro to print it. And already we've seen few more times. I'll talk about the normal string and the string type in some future video, but that is a very important distinction to make. But this string is used everywhere. A normal string is a static string which is not usually very commonly used. And like this name and age and salary, you can define the different fields. And string colon from. The string is a part of standard library. We from this static string we constructed there is an ampersand string, ampersand star, and a capital string. This string is allocated in heap. That string is allocated in stack memory. So using this string we can add, append, or you can allocate inside heap and manage the string appropriately. That I'll discuss in some future videos, but this is just to talk about the struct. So here we define and create an instance of an employee. So employee got printed. And we can access any field by using dot operator, employee.name, employee.age, and so on. And this is a different type of struct, pair. We no need to use curly bracket here during initialization also. We can use parentheses and pass the values, and we can use it. And to access, because there is no field, we have to access using .0, .1, and so on. This empty struct is a special kind of struct. It is just used for the type checking and some specialized purpose only, not very commonly used. Empty. It doesn't store any value as such. So the relevance of it is very minimal. Here this is the destructuring syntax. In the left hand side, if you use employee and curly bracket and name as salary, this is you are transferring this ownership of employee, but you are destructuring into name, age and salary. So you can print like name, age and salary in a different access as a different attribute, as you don't need to use emp.name. Similarly, this tuple type also you can do that. This is a destructuring syntax. Final topic for today is enum. Enum is very commonly used across this Rust. It is very much popular and more powerful concept. Enum is a simple term. It can contain different value, but if you declare a variable, it can contain only one value at a time. If you define a variable color, it can contain either red, green or blue, not all three value at the same time. So we use using the let keyword, we define the color. The type is color, not red, green, blue. All this type would be color type only. So it can contain only one value at a time, color red. And to access values, we can use pattern matching, like match keyword, match the variable name, and we have to implement for all the three type. Red. So these are the three different arms. So this color can be red, green or blue. If this color, once we match it, if it is red, then this will be executed. If it is green, this will be executed and so on. So we have to provide the implementation for all three. Red. And this debug information is not very helpful. It will simply put the color is red if you want to see this, which actually the values. Now the powerful of this, we define another enum message. So apart from this data itself, we can store different values here. For example, we can store the value in a struct format, x and y. We can store the value, this is not a payload, we can store the value in a tuple format. So this tuple, once you declare message, it can contain different types. Message can have like quit, move, write and change color, and at the same time it can contain the different payload as well. Now we have like one type is change color. This is not a function, this is just a type. Now we have to implement for all the different type. So I have provided implementation, but if you see here, we are using like head arrow key syntax, and this is simply the println statements. And here I am using the curly bracket. This is also a different way to, you can use the simple println in the one line, or you can use curly bracket if you want multiple line of code. And using this, you can access the value like x and y. Here I'm accessing the value like color, and I'm printing in a debug fashion. Because color I given like debug macro, I can able to print it. So change color to blue, because I pass like change color. This change color is not a function. This is simply a enum type, and which contain a payload of blue color. And one enum can contain a different enum type, because this enum type as value of color is also a different enum. And we can use like type alias in some cases, like if the message is very small one only, but if it is a lengthy name, and if you want to give a type alias, whether you refer using message or message is the same thing. For example, so here I am using the message and message here. Both are same thing, because I am using a type alias here. Okay. This is a string literal, but this write is expecting a string type. String and string literal type is a little bit different. To convert to string literal to string type, there are different ways. So we can use like dot to string to convert to small star to a string. Once I talk about like the memory model, like how heap, stack, and represented, then I will discuss about like string literal and the string and the string type in more elaborately. So see, this is a variable shadowing. You can use any number of type. You can write message again and again, so it won't cause any issues. You can declare initially multiple times. And inside that, if you don't want to use this message again and again, you can import inline inside in a function or method anywhere you like. So in this case, it will be imported all the time. So you can directly give that quit, move, and write and change color. You don't need to give that module name message colon again. So which will work as it is, as before. And before I wrap up for today's video, I would like to give a big thanks to this Rust by example book. Most of my examples are derived from this book. I'm going chapter by chapter and coming up with these examples and concepts. So I'll give this link of this particular books in my description below. I highly recommend to check out this book and go through this in more detail. So thank you for watching. Have a good day ahead. Bye bye.